Hello, I'm going to be showing you the new Chaos module that we've added to WireMock Cloud. Over here on the right, I've set up a very simple mock API. All it's got is 3 stubs, 1 post and a couple of gets, and they all just return 200s. Over here, I'm running a load test using the torus over the top of Gatling, which is showing us that our latest interval up here, you can see the response time percentiles. You can see that it's jumping around between about 150 milliseconds and 300 milliseconds. Showing us our response codes, 100% of them are 200s. There's a graph down here of the response time in blue. And you can see a sort of information about any errors that are coming through in this box at the bottom. And as you can see, everything's going fine at the moment. We're returning fast and we're returning successful 200s. So let's add some chaos to the mix to start breaking things. So we go to the chaos setting on the left-hand side. We can click to enable chaos. We can choose what percentage of requests across all the different stubs we want to fail. So let's set it to 10. And we're going to add some HTTP errors to start with. So we're going to add in some 503s and some 500s, as these are common ways in which applications start failing. And click save. And we should very rapidly start seeing problems coming across through. And we can see now we're getting 503s and 500s coming through. You can see them showing up as red here. And we're getting about 10% of requests failing. Yeah, you can see up here too that 200s are dropping down to around 90%. It's we're not perhaps running hot enough to show it exactly 90%. But you can see it's not making much difference to the percentile response times because all it's doing is returning the response code. So let's have a play with the response times as well. Commonly when things are breaking, the response times start going high, so we can add in a new failure type of long delay. So if we push this up to 15%, that will mean that 5% will be returning 503s, 5% 500s, and 5% will be having a 5-second delay. Let's make that just slightly higher. We'll make that 5,100. Hopefully what we'll see is the 95th percentile response time go up to 5 seconds. And there we see it go. So the 95th percentile response time now just over, sometimes it's 5 seconds, sometimes not, depending on how lucky we get at any given interval. We can see that the average response time is now shot up. Because we're getting a bunch of them now hitting these long delays. And now we can, however, we can put everything back to normal by disabling chaos. And we should see everything recover. And we see, yeah, the 100%, so 99.9% our response time back down to normal levels. We're no longer getting any errors. We're getting the same throughput we were getting before. Average response times drop back down. So everything's recovered. Our API is back to normal. The last thing I'd like to show is that we have a class of error that a lot of people can't provide, which is that we can actually muck about with the network connectivity. So we can just close sockets on you. So let's put that in, and I'm going to put it in by itself. The reason I'm going to show this in isolation is, and at quite a high level, is that actually a lot of load testing tools are clever enough to recover and retry on socket close exceptions the first few times. So in order to get it to fail enough, you have to turn it up relatively high. So we'll turn chaos back on, we'll save, and we should start seeing lots of problems coming through. And you can see now we're getting I/O exceptions, premature close, because now the remote service is just closing the socket on it. You can see now the sea of red beginning to come through. And we're getting, yeah, somewhere around 35% or so failure. As I say, this is skewed a bit by the load testing tool actually handling the problem and trying again. And once again, we can just scale that down to 0 and see it recover. And yeah, we're back down. The red's gone away and everything's looking good again. So why would you want to do it? You'd want to do it in order to prove that your clients behave appropriately when your service is misbehaving. So hopefully that they open a circuit breaker so they stop throwing load at you, that they don't overload you, that they don't leave connections lying around, that they return sensible error messages into your monitoring systems and to your end users. Thank you very much.